today I need to leave. Once my talk is done, I need to leave. I need to do the school run today. But tomorrow I'm back at the conference. I'll be here. I'll just admit somebody here. Welcome. I'll be here with you from tomorrow morning from the coffee break onwards and for lunch as well. So if you have questions, in addition to the questions we discussed today in the Q&A, but if you have more questions, you want to chat a little bit, I'll be here tomorrow as well. And I'll very much look forward to the sessions tomorrow as well. All right, so what is the plan for today? So I'll be talking, as you've seen, about implicit and explicit learning of Chinese as a second language. So the plan for today is very simple. I'll start off by explaining what is implicit and what is explicit learning of language. It's the main topic I've been working on for many years now. And then the second part, I'll give you an example of how we do research on implicit and explicit learning in our research group. So I'll just give you two examples, right? I want you to have an idea of how we do experiments on this topic. And then in the third part, I'll reflect a little bit about implications for future research, but also pedagogical implications. I didn't teach Chinese, of course, but I've taught German as a foreign language and Portuguese as a foreign language at university level. So before I did my PhD, I taught language for 3 years, so I know what it's like to be a language teacher and to deal with the challenges that this involves as well. Okay, I hope this sounds good. So I'll kick off by introducing you to our team, several of whom are here. So we have Yuki and Kelly, and Shopang is hiding over there, and Jai is hiding. Shopang is the gentleman with the white hat, which he put on purpose. So Shopang is an undergraduate student of ours. Jai, Kelly, and Yuki are PhD students, and the rest of them are currently in Lisbon at the summer school, I think. The reason I've been starting to work on Chinese as a second language really is due to my Mandarin native-speaking students. So Sichi, Jai, Kelly, Wense, Yumo, Cindy, Yuki, and Summer, in addition, of course, to undergraduate students like Chopin. So over the past few years, we've done quite a lot of work on Mandarin. So we've done several studies looking at the acquisition or the processing of L2 Mandarin. So how do native speakers of other languages like English or Portuguese process or acquire second language Mandarin? We've also done studies looking at how Mandarin native speakers, so people like most of you here in this room, how do Mandarin native speakers acquire new languages, usually English or Portuguese? And we've also done work, and it's primarily Kelly's work, really looking at language processing Mandarin English bilinguals. So people who are dominant in Mandarin and who have learned English, how do they process language? Okay. So, well, let's start off with definitions. So what is implicit learning? Implicit learning is the incidental acquisition of knowledge about patterns of regularities in the environment, right? So the input that we're exposed to without awareness of what has been learned. Okay, I'll just read this quickly, not quickly, very slowly. So the incidental acquisition, incidental means you don't know what you're supposed to learn. You just pick it up like this from the environment. Okay, it's not intentional, it's incidental. And the other important feature that it's about patterns or regularities. So this could be, for example, associations between sounds and meaning, or it could be grammar, for example. And the third component here, if there's a pointer. Is there a pointer? It must be. Yeah, there's. Third component is this one. So it's learning that results usually without awareness. People not aware that they're learning. Okay. The classic example of implicit learning in the wild, in the real world, is language acquisition, especially in infancy or childhood, because we all can all agree that the infant, when they're learning Mandarin or any other variety of language, they don't consciously set to memorize 75,000 words, and they consciously try to learn the rules of grammar. Infants and children learn language by exposure and by interaction, right? And the knowledge that you acquire as a result of massive amounts of exposure, of interaction, is largely implicit, okay? You know that you know, but often you cannot really explain why. That's a classic example of implicit learning and implicit knowledge. There are many other types of examples. For example, social interaction, music cognition, very good example as well of implicit learning, right? All of us, even if you're not a musician, if you're exposed to musical systems in the world, for example, Western tonal music, you develop the grammar of music, even if you don't play an instrument. We can tell this very easily when we play a musical sequence and you have a sour note. Everybody can say this doesn't sound good. They can tell so because it violates, the sour note violates the rules of the grammar. Or for example, if I play a musical sequence and I stop it and I can say, what do you think comes next? This note or this note, everybody can do it, even if they're not a musician, right? So implicit learning is usually contrasted with explicit learning. Explicit learning is a different type of process. Here we're talking about intentional acquisition of knowledge. So this is when students sit down and they consciously try to memorize rules, they try to discover rules, for example. And here learners are aware of what is being learned. So it's when we tell students what they're supposed to learn. And often, as a result of this process, learners are able to explain the rules that they've noticed. A classic example of explicit learning and explicit knowledge is grammar rules in the classroom. So if you tell it, for example, that in German, the finite verb comes at the end of the subordinate clause, you all have explicit knowledge of German, all of you, right? The finite verb comes to the end of the subordinate clause. That's an explicit rule of German. There you go. Can you speak German now? No, of course you can, because it's a well, maybe you can if you've learned German. But that's explicit rule knowledge of German. And that's very different from the ability to speak German, right? Likewise, we use this as well if you're teaching Mandarin. I'm sure you raise awareness, for example, of the tones, or you raise awareness of the syntactic structure. All of that is explicit, right? And that's what essentially what I've been looking at since almost 20 years now. So if you look back at the definitions, two things that are particularly important usually is to emphasize that implicit learning is associated with incidental learning conditions. People don't know what they're supposed to learn. And that's usually knowledge that results in, or it's a learning process that results in unconscious or implicit knowledge. And explicit learning is associated usually with intentional learning conditions. You know what you're supposed to learn, you know you're going to be tested, and then it usually results in conscious knowledge. Okay. I'll share these slides with you, so you don't have to copy everything. I'll share the slides. So if you look at implicit and explicit learning, for example, we can look at different features. We can look, for example, at whether awareness is relevant or not. So with implicit learning, no awareness of what is being learned. In contrast, in explicit learning, we have awareness of what is being learned. In terms of intentionality, one process is incidental, the other one intentional, right? And one you don't know you're supposed to learn, and the other one you do. In terms of control, one is more unconscious, the other one conscious. And then the focus in implicit learning usually is not metalinguistic. You don't talk about rules. Whereas explicit learning, the classic example of explicit learning is learning rules, metalinguistic rules. And then if you look at the end of the learning process, right, we learn and then we acquire knowledge. That's either implicit or explicit. Very big topic in SLA research. How do you tease them apart? Can you distinguish implicit knowledge and explicit knowledge? For example, we know that implicit knowledge is very difficult to verbalize, difficult to explain. You just know that you have it. All of you have implicit knowledge of, for example, your native languages. Explicit knowledge is different. It's something that's available to consciousness. You can explain it. Okay. One is used more automatically, intuitively. The other one requires more conscious effort. And then in terms of stability, one is more robust, long-standing, and the other one less so. That's the basic idea between implicit learning and explicit learning. That's essentially what we're looking at. So I want to show you now two examples of implicit and explicit learning research that we've done in our group. So the first one is a study done with Cindy and my colleague Patrick Monan. This was published in the journal Bilingualism, Language and Cognition this year in 2025. Okay, the paper is called The Role of Phonology in Non-Native Word Learning, Evidence from Cross-Situational Statistical Learning. So I just want to show you how we do this type of research. Okay, so here's kind of use this also to introduce you to the methodology, how we do research on implicit and explicit learning of languages, in this case, of Mandarin. So in this experiment, we have two groups. We have Mandarin native speakers, and we have native speakers of British English without experience in learning Mandarin. So these are what we call naive. They don't speak Mandarin. And we have 12 Mandarin pseudo words. So there could be words, but they're not. So all of these words, as you can see, are disyllabic. They have 2 syllables, right? They're not real words. They don't exist. The reason we do this is to control for what people have been learning before. We control. It's an experimental study. We want to have good control. So these are words that could exist in Mandarin, but they don't. And as you'll see in the numbers, 1 and 4, we look at 2 different tones. So let me just show you what these sound like. Oh, let's see if that plays. Oh. A problem with the sound. Codec unavailable. So you'll just have to take my word for it. So it's one of them, Kelly, since you're laughing and you're native speaker, how would you read them out? So read kind of, okay. Sorry, can you do the 2 again? Okay. Right, so these are the words. It was recorded by a native speaker of Mandarin, Cindy in this case. We have the 2 tones, right? And they're nicely recorded. Okay? So there are 12 words that could exist in Mandarin, but they don't. Call them pseudo words. These pseudo words are randomly associated with these objects. Again, these objects, nobody has a name for them. That's why we use them. Okay? So they're novel and unusual words from a database developed by Jessica Horst. And so each of the words, like Pami, is associated with one of these objects at random. Okay, and this is our task. It's very, very easy. So you see 2 objects, one on the left, one on the right, and you might hear Pami, right? You hear it only. You never see anything written. Okay, and then you have to make a decision which one is Pami, the left one or the right one. If I were asking you, half of you would say the left and the other half would say right. Okay, there's referential ambiguity. You don't know which one is which. You don't know, you can't know, so you would have to guess. Okay, the key thing here is that you don't get feedback. So if you don't get feedback, how can you learn? You don't get feedback, and there's referential ambiguity. How can you learn this? So the reason, or the way you can learn this, is by keeping track of cross-situational statistics. So cross-situational statistics means statistics across learning trials or learning situations. Okay, it's a type of implicit learning. For example, if you go back now to our stimuli, for example, the first trial, that's the first thing you see, these 2 objects, and you hear Pami, right? Then you see these 2 objects, and you hear this word, and you have to make a decision. Is it the left object or the right object? Then you see these 2 objects, and you hear Leifa, and you have to say, is it left or is it right? And you don't get feedback. But when you get to the 4th trial, you hear Pami again. And there's only one object that occurs again. Only one object. But remember, you do this for 12 words, you can do it with 24 words or more. It is a difficult task because if you try to do it consciously, it's very, very difficult. But we don't tell people to do it consciously. We just tell people, hey, listen to the words. Is it this or is it this? That's it. Okay, cross-situational learning. Or in this case, it's a type of statistical learning. Okay? So the way people solve this, the way people learn these Chinese words, by Chinese words we mean associating an object, a visual reference, with the pseudo word like Pami or Leifa. It's done by cross-situational learning. Okay, let me give you. I don't think you'll be hearing. I think the sound won't work. But this is screen experiment. I don't think you'll hear the sound. Oh, you do. Left or right? Left or right? Enter the response. So each time you hear the word, you make a decision, left or right. You don't get feedback, you get the next one. So what do we find? So this is how we present our results. You see on the y-axis here, the proportion correct. The dotted line is chance. When people are guessing, they should be at 0.5 or 50%, they're guessing, okay? Roughly, that's what you see at the beginning. So the red line is English native speakers, the green line is Mandarin native speakers, and initially they're kind of guessing, right? Like all of us would be in this room. Very quickly, people are not guessing anymore. What happens is that people quickly learn these new words, right? These new mappings between the sound and the visual reference. So what we see is that from block 2, which is very, very early, which is here, after around 24 trials, people are not guessing anymore. They've implicitly tracked the statistics, and they're starting to learn these Chinese words. By Chinese words, I mean the label, like Pami, and an object that is associated with it. And so all of this takes less than 10 minutes, right? We didn't do it explicitly. We didn't tell people, oh, find the words. They just learn it. That's very good news. That means a lot of the stuff that we do in the classroom, we don't need to do explicitly. We can just do it implicitly, which is good because in the classroom, you can focus on stuff that is actually difficult for participants. These labels, they're relatively easy. Okay. So most studies that use artificial languages use pseudo words that are very, very distinct, very, very different. For example, you might have pseudo words like these, like Barget, Bimda, Makot, Nelby. The words are very different in terms of the phonology. They're phonologically very different. But in real life, of course, there's often overlap. So if you look at an English word like cat and mat, they form a minimal pair, right? They're almost the same with one consonant difference at the beginning. Cat, mat, hat. These are called minimal pairs. And they're very frequent in language. So if we go back to our pseudo words, we'll actually see we have minimal pairs as well. So the 12 words that we have, they form minimal pairs. For example, you can contrast Tami and Tami, or Tami and Kami, and so forth. These are consonant minimal pairs. I'll explain this a bit better in a second. You have tone minimal pairs. So words that are identical, but there's one different, that's tone, which of course is relevant in Mandarin and other Asian languages, but not so much in English. And then you have vowel minimal pairs, where everything is the same, but the vowel is different. So lifa, lufa. That's a minimal pair as well. But here the difference is just a vowel. So let's go back to the task. That actually means in the task, there are 4 types of trials. The first one is the most basic version. So for example, you see the 2 objects, and you hear Tami. And the words that are associated with the objects, you always hear just one word, right? But the word on the left, that's really associated with Tami. So we call that the target. This one is associated with Rufa. That's what we call the foil. So the correct decision here, if you hear Tami, you have to press this one, okay? Because the words associated with these objects do not form a minimal pair, we call these non-minimal pair trials. But you always just hear one word. So these are the one type of trial. And then you have 3 additional ones. So the first one, imagine you hear Lifa, you see these objects, and one of the objects is associated with Lifa, and the other one with something else. So in this case, you have the one on the left associated with Lifa, the one on the right with Lufa, right? And Lifa and Lufa form a minimal pair, a vowel minimal pair, right? But you just hear one word. Then in the other type of trial, you might hear Pami. You see 2 objects. One is associated with Pami, the other one with Pami. And that becomes a tone minimal pair. You just hear one word. And last but not least, you might hear Kami. And then you hear Tami and Kami. And that forms a consonant minimal pair trial. Okay? So can you see that this makes the task makes it much more difficult? Because you can imagine when the target and the foil objects, when they're associated with words that are similar, the decision is more difficult. That's exactly what we find. So these are the Mandarin native speakers. When we now look at the minimal pair trials, at the top one, the red line, this is when we have non-minimal pairs. Non-minimal pairs means they hear one word, but the words associated with the target and the foil objects do not form a minimal pair. That's the easiest task. For people, that's very, very easy. Look how high they get close to 80%. Very, very easy. But when we start having minimal pairs, it becomes more difficult. For example, we see this here with consonant and vowel minimal pairs, right? People can still do it easily, right? Easy enough, but it's easier if it's a non-minimal pair. And tones, slightly more difficult, but it's above chance. Mandarin native speakers can handle this. This after 10 minutes, okay? What it kind of tells you is when you're learning these new words, very quickly, you form a representation in your memory of the word that you heard, and it becomes more and more accurate as you complete the task. But let's look at the English native speakers. So Mandarin native speakers can do this. I'm not surprised, right? What about the English native speakers? This is what happens with English native speakers. They can also do it. And you have a very similar pattern. It's easiest for them is with non-minimal pairs. Then when it's vowel minimal pairs, then consonant minimal pairs. But when it's tones, English native speakers have a really tough time doing it. So they have trouble distinguishing between two objects that are associated with pa-mi and pa-mi, because the tone minimal pair, yeah, becomes difficult for them, which makes sense. However, one thing that's very interesting, this data set is actually, we also tested individual differences. We checked how good people are at hearing differences, English native speakers. It turns out that English native speakers who have good hearing, who have good auditory acuity, especially those who have good pitch perception and who have good melodic memory, they can actually do it. So not everything is lost for English native speakers. It's only after 10 minutes, okay? But it shows you the importance of individual differences. It's not that nobody can do it. Some people can do it. And it's people who have good pitch perception, good melody reproduction. So there's individual variation. Okay, and that's something we're very interested in our group, this explaining the individual variation. Why are some of us better at learning languages like Portuguese or Mandarin than others? Okay, so what have we learned from this first experiment? So we know that adults can learn new words implicitly. We know that segments, consonants, and vowels are easier to learn than tones. But of course, you still learn the tones eventually. We know that Mandarin native speakers outperform English native speakers, especially on tone minimal pairs. What this shows you, of course, that your L1 matters. If you've learned Mandarin and you get new words that follow the phonology, the sound system of Mandarin, you'll do better. So that's an advantage because of your L1. So L1 makes a difference. We also know that some English learners can do it, particularly those with good pitch perception, good melodic memory. This is what we do here is we use battery developed by Kazuya Saito, who's an expert in alto speech perception. He developed a test battery that measures listening abilities for second language learners. And the battery is freely available on a website that he called SLA Tools. So you can use that as well if you're interested in the effect of auditory acuity on learning. Okay, so individual differences play an important role in implicit learning. So this brings us to the second study. The second study is similar to the first one. This study done just with Cindy is currently under review. And we just presented this last week in Norway at a conference, the European Second Language Association. So we've seen in the first experiment that participants can learn the new words. And we've seen there's individual variations. Some of us learn better than others. Okay? And so we're very interested what happens. Can we help people learn through instruction? A lot of you are teachers, right? Can we help people learn Mandarin tones through instruction? What can we do? And so in this case, we thought the challenge for the native speakers of English here is the tone perception. It's not the vowels, not the consonants. Let's forget about consonants and vowels. Let's focus here on the tones. And so in this experiment, we looked specifically at the effect of instruction and awareness of the tones. Does that help you learn the Mandarin tones? So now we have two groups. They're all native speakers of English. They haven't learned Mandarin before. Right, so we control exposure. We don't want them to have learned Mandarin before. And we have two groups, an incidental group and an instructed group. The incidental group does the task that you just saw. We just tell them, hey, welcome to the study. You're going to hear a word and you're going to see two objects. Your task is very simple. The word that you hear is associated with the left object or the right object. That's it. We don't tell them it's about learning Mandarin. The instructed group is different. We tell them something about the language. Other than that, the groups are the same. This is like you saying at the beginning of the class, hey, I want to remind you of a rule, and then you do the task. This is giving a pedagogical rule at the beginning. The words are exactly the same, but now we made a small change. We've actually used real visual Chinese characters. Of course, they mean something completely different. We selected these because the single component characters, 3 to 4 strokes, are relatively easy. But instead of having the other objects, we now have the characters. And this is because Cindy is very interested in studying also how people learn, non-native speakers learn how to write in Chinese. So a lot of research now on non-native speakers learning how to write Chinese. But so each of these words, each of these characters, which has a real meaning, of course, is associated with one of these pseudo words. Okay, that's essentially what we're doing. And as I said, we do this to control for what people have learned. Good. The task is very simple. Left or right character. Left or right. You have to remember, for you, this is weird because you know what they mean. But our participants don't know what it means. For them, this is li fa or lei fa or something like that. Okay? We do this to control. You could use real Mandarin words for this. The problem with that is that you lose control because people can hear Mandarin outside of the lab. And we want to control for that. That's the only reason. But you can do it with real Mandarin words. So again, they don't get feedback. And again, we have these types of trials, the consonant minimal pairs, vowel minimal pairs, tone minimal pairs, and the non-minimal pair trials as well. So both groups complete the word learning task that I just showed you. And only the instructed group is told about lexical tones before the word learning task. As I said, this is like saying in your classroom, you have, imagine a meaning-focused activity about word learning or grammar learning of Chinese. In one of the groups, at the beginning of class, you say, hey, before we do our class today, where we're focusing on meaning, I want you to remember that in Chinese, for example, there are these tones, and this is how they function. So what we're doing there is you raise the awareness of the existence of tones, and you hope that this then will improve learning. So I'll show you what we did. Very, very simple. So we raised the awareness of the tones and the roles they play. And this is what we did. So before the word learning task, we told people, pay attention to the tones of the words. Listen carefully. Can you hear the difference in tones? Now this, I think you're not going to be able to hear. Oh, you can. Okay, this is what they hear. We do this multiple. So we raise the awareness of the different tones, and we see, can you hear them? Then we test them if they can actually hear it. Which one is different? The first one. Hey, you seem like, you're native speakers of Mandarin. I mean, the interesting thing is I can hear the difference easily, like this. So it's not just about, so all of our participants, when we do this at the beginning, all of them, they can do it. The English native speakers have never learned Mandarin, they can hear the difference, easy. So the question is, now they know there is a difference, does it help them learn? Okay, that's what we're interested in. At the end of the experiment, we asked people if they notice the tone, if they notice the pitch patterns, did they notice, were they consciously aware of it? And what we do with this is then you transcribe everything, right? You transcribe and you can then code people as being aware of the tone or not aware of the tone, right? Based on what they say at the end. And then you can analyze the data and see, okay, does awareness make a difference? Does it make a difference if people become aware of the tone? Does that help learning? Okay, so let's look at the results. So do participants learn the Mandarin pseudo words? The previous experiment showed us that they should. And yes, they do. Okay. In this case, it's not with these crazy objects, it's with real Chinese characters, it works. And if you look at the lines, they're very, very similar. There's no significant difference here between the two groups, the incidental and the instructed condition. And again, they're above chance from block 2. So very, very fast to get these effects. Does phonological similarity make the task more challenging? Based on the previous study, we should say yes. So let's have a look at the two groups, the incidental group on the left and the instructed group on the right. The red line at the very top is the non-minimal pair trials. Okay, And again, you see that those are the easiest ones. Then come the constant of all minimal pairs. And then interestingly, again, you see the tone minimal pair trials are very flat. Flat, in this case, people are just guessing. So when people hear a trial where they hear, for example, lay fa, and they see two objects, and one of them is associated with lay fa and the other one with lay fa, they have a really tough time distinguishing them. They're guessing. That's all it means. It's true that's only after 10 minutes, okay, but still. So this replicates what we found in our previous studies. But the key thing is, does it make a difference? The fact that we told them about the tones. And it doesn't make any difference whatsoever. And this is what you can see at the very bottom, here, here. So remember, we told them about the tones. We told them, hey, in this case, there are two tones. We checked, do they actually remember the tones? Can they hear the difference? Yes, they can easily. They can hear the difference, over 90% accuracy. They tell us they perceive the difference, but it doesn't help them learn the words. But when you look at the verbal reports at the end of the experiment, remember we asked them, hey, did you become aware of the tones? The incidental group, we didn't tell them about the tones. So if these people were at the end, if they tell us, oh yeah, there were some tones, we didn't tell them, they noticed it. So the way we do this is we divide the participants basically in aware and unaware. And the unaware are people who say things like this. I didn't think tone or pitch was used at all. That's unaware, okay? Minimally aware are people who would say like, I only realized there were tones when directly asked about tones. Well, they mention it at the very end when we prompted them, fine. Let's say they're minimally aware, a little bit of awareness. Then you have people who are partially aware, right? I noticed tones or pitch after being asked about sound patterns. And then fully aware, these are people who said, I used pitch or tone to pick the right word as a strategy. So these are people who tell us, hey, yes, I noticed their tones and I picked, this is how I made my choices. So does that make a difference in terms of learning? And this is what we can look at now. So what this shows you is for the different awareness levels, unaware, minimally, partially, and fully aware, you can look at the average accuracy in the task. What you see here first is that people who are unaware, who say, no, I didn't notice anything about tones, they still perform above chance. There's still a learning effect. They still learn. Okay, so it shows you that implicit learning can occur without the conscious awareness of the tone contrast. But what we also see is that as people become more aware, based on the verbal reports at the end, they tend to be more accurate. And the group that is most accurate is the one that is fully aware. This one here. Actually, it's the mean is actually similar to this one here. So it's around 75% accuracy. Okay, what this suggests is that awareness is not essential. It's not essential because these guys are not aware, but it's clearly beneficial. So it's good if you become aware of things. So what have we learned in this experiment? So we've learned that adults can associate Mandarin pseudo-words with Chinese characters through implicit learning. So we're looking at the fundamental mechanisms underpinning learning. Of course, you can make it more complicated. You can make it more complex. You can do this over multiple days. You can do it with real Chinese words. But this shows you that fundamentally it works. We've seen that the minimal pairs increase the task difficulty, especially when you're looking at tone contrasts, which are difficult for native speakers of English. We did find that explicit instruction of tones didn't directly facilitate learning. But we noticed that learners have awareness of tonal features. So becoming aware of the tones, either spontaneously, as in the incidental group, or prompted, that means when, as in the instructed group, predicted learning outcomes. So it's not so much about the instructions, it's becoming aware. And then you can think about things like, well, why do some people become aware and others don't? What is it about the learners who become aware? Okay. 5 more minutes. And then we have time for questions. So let's think about the implications for teaching and research. Right? So these, of course, are lab-based experiments. We do a lot of these. You can make them longer, you can make them shorter. I mean, this takes about 10 minutes. Very easy to get the learning effects. We do other studies where, for example, we use real language, so real languages like Japanese, for example, or Portuguese, and we give them multiple days of training. So you can really do this with a real language. It works just as well. It works with, if you're learning simultaneously words and grammar, that works as well. So we have several studies published on this as well, except we usually don't look at Chinese. So most of the work we do on Chinese looks at the acquisition of the sound system or words. Okay, implications for teaching and research. So the first one, this is pure speculation, right? Because I don't teach Mandarin, but I'll be interested to hear what you think. So rethinking tone instruction in the classroom. So we know that instruction alone isn't enough. Becoming aware seems to be the key. So it's not enough for us to say, hey, are you aware of this? And here's, for example, I gave you a German rule earlier, right? Does that make a difference? And sometimes it doesn't. We need to use rich input and perceptual support, not just rule explanations. One thing that we know from the research that we do is that people need a lot of input. We learn very fast. As I said, these experiments take about 10, sometimes 20 minutes, sometimes 40 minutes, right? But the more exposure people get, the better. And so here, for example, one thing that's very promising is the use of GPT and similar type of platforms. This is something that colleagues are exploring with regards to other languages, like Spanish, for example, but it would work with Mandarin as well. So a system like GPT is at least great for providing authentic inputs in the foreign language and interaction. So what we know from the research we do is we need a lot of input. The more we get, the better. And if then we become aware of features, then that boosts learning. So very importantly, we need a lot of implicit exposure. Again, as I just mentioned, this is not something we can often provide in the classroom because classroom time is limited. I don't know how long. I mean, when I was teaching language, maybe it would be like 3 hours a week, 4 hours a week at the very most. But look how long it takes to learn your first language. It's dozens and dozens of hours every week, right? So as adults learning a new language in the classroom, the time is very limited. So the question is, how can you expand opportunities for practice and for input? Nowadays, it's much easier. So things like GPT, for example, work quite well, actually, because GPT can give you a lot of this. GPT is not very good with some things, but some things are very good. So GPT is very good with giving you real, like, kind of authentic conversations with good input. So it's grammatical input. Not very good with correcting mistakes. GPT forgets easily, right? So you can tell her, please correct me, and then GPT forgets. You can ask GPT, hey, adjust to my proficiency level, and then it forgets as well to do that. But GPT is very good at providing input and doing interaction, real interaction. So we need to maximize the amount of exposure that our students get, but then also use maybe the classroom to provide opportunities for reflection. So imagine outside of the classroom, the students engage in Mandarin, for example, through chatbots like GPT, and they get the opportunities, and maybe they notice things, and this is what they can discuss in the classroom. They can bring it back, because we know that awareness is very important and boosts learning. And then if you're interested in using this strategically in the classroom, for example, developing tasks that help learners notice tone, contrast, and context could be very valuable as well. In our case, we feel that it's better if learners do the noticing rather than us telling. So what we see here is that when we told people about, hey, look, these different tones, it didn't make much of a difference. But when they noticed it, that's when it became powerful. So can we develop a task, for example? Imagine a rule search type of task where your learners work, for example, in a group and have to discover rules that underlie the syntax of Chinese, for example, of Mandarin, or some aspect, something that's rule-based. Or for example, how you interpret the characters, that you have the semantic radical, and here's a cue that tells you the meaning, that gives you a clue for the meaning, and the other one gives you a clue to the pronunciation. These things, if people can figure it out themselves in the classroom, could be more powerful than just telling them. Right? So not always, but sometimes getting the students to figure it out as a group, try to discover, is often more powerful than just telling them. Then the other thing that we know from a lot of the research we do is that there's a lot of variation, right? I mean, look around this room, right? There's a lot of variation, and it's wonderful. On the one hand, we're all the same, we're all human beings. On the other hand, there's a lot of variation because some of us have really good memory, some have really good hearing, some have very good hearing but very bad memory, all of this, right? And traditionally in the classroom, this is very difficult because this variation is often difficult to handle, even differences in proficiency. You know, one person might have been done a summer school in China for 6 weeks and the other people don't. So there will be differences, right? How do you do this? Again, in my experience, also in my research experience, this is where technology can be very, very helpful. So in the classroom, it's difficult to adjust teaching to specific learners, but technology can do that really well now. So Gen AI tools that we use in our research, for example, can individually adapt to the learner individually, right? So rather than everybody gets the same type of instruction, what you can do with Gen AI is to adapt the instruction to the learner outside of the classroom. Just like taking the learner by the hand. Everybody gets the type of input when they need it and for the different aspects. So embracing learner difficulties, not difficulties, differences. So we need to try to adapt teaching to account for variation. For example, auditory aptitude or learning profiles. It's a challenge to do that in the classroom. It's easier to do it outside if you complement your classes with technological tools. If you want to do this in class, for example, you can start with simple diagnostics. So you can see, for example, are there differences in your class in perception of the tones? Can you, for example, group them people depending on how good they are at listening, for example? Also, you know, often there's variations in how we like to learn. Some people like a more visual, some are more auditory, some more tactile. So can you, for example, use multiple modalities? For example, one of your learners might not be very good at hearing the tone difference, but they might be very receptive to, for example, visual cues. Right? The visual cues might be very powerful as well in helping this, or gestures, or other modalities. And then, as I mentioned, for us, what works particularly well is not necessarily teaching or telling people explicitly the difference of the tones, is actually helping them discover it themselves. That's not always necessary. We have studies where simply telling people about the grammar boosts learning. But in this case of the tones, it seems to be more beneficial if people can discover it by themselves. Right? So for example, can you give tasks, can you give materials, authentic materials, for example, Mandarin, where people have to listen, have to start with colleagues, with other learners, for example, try to discover the number of tones and so forth. And then last but not least, the final slide, just looking at research in the Chinese SLA, and I hope you'll join me and conduct me and my students in conducting research in this area. And the first thing, so, okay, I should preface this by saying we know a lot about how English is learned as a second language, right? I'm not a native speaker of English. Most of you are not native speakers of English, probably. And yet here we are talking English. English is the most widely studied language in the world, and it's useful because we can communicate. However, we know a lot about English, and then we know a little bit about Spanish as the second language. But in comparison to the richness of the world, we know hardly anything about Mandarin or Portuguese or other languages. And these are big languages, right? So smaller languages, we know even less. So it's really important to have a much better understanding of how second language learners, for example, adults, learn the sounds, the words, and the grammar of Chinese over time, right? And I think this is an important change that's been happening in recent years. So at the conference I just went to, Euroslat, it's the biggest conference in the world on second language acquisition, full of Chinese scholars. And interestingly, they study Chinese. So traditionally, when I get Chinese scholars to work with me, they're usually interested in English. That has really been changing a lot, which is very good, I think. So more and more Chinese scholars are now studying how Chinese is acquired, which is good because if Chinese scholars don't study it, who is? It's important. So we need to have more understanding of how the sounds, the words, and grammar of Mandarin and other varieties of Chinese are acquired. Then very important, we need to look very systematically at the effects of instruction. So broadly, when we look at this, we look at implicit instruction and explicit instruction. So the two big clusters or modes of instruction. Implicit meaning people don't know what they're supposed to learn. We need to know this so that we know what we don't have to teach, right? You cannot teach a language explicitly. That becomes linguistics, right? Your students don't want linguistics. They want interaction and so forth. So we need to know what we don't have to teach because people can just learn it from exposure. right? And then we need to know what needs to be taught explicitly. For example, in the case of English or other European languages, one of the challenges of morphology. That's why a lot of studies focus on the explicit instruction of morphology, because it's often difficult to learn. So words in English are easy to learn. The syntax is okay, but the morphology is sometimes very difficult. It's difficult because you don't hear it very well. It's often redundant. So if I say, yesterday I walked to the beach, right? When did it happen? Yesterday. How do you know? Well, there are two cues. There's yesterday, the adverb, and there is the ed in walked. But the ed you don't hear. You really don't hear it because I say walk to the beach, and the walk to the beach, the to, is hiding the ed. You don't hear it. There's none. So we don't need to pay attention to the morphology. We can pay attention to the adverb. Because of that, you know, it's acquiring morphology is more difficult, which is why it's very good as a target for explicit instruction in the classroom, because we can raise awareness of morphology, you know, in our classrooms, and then this makes it easier to learn. So we need to have more systematic investigation of instruction, implicit and explicit learning, and learning Chinese. Then we need to understand better individual differences. That's something we're working on. So for example, why are some of us better at learning Chinese than others? So what is it? Is it our auditory processing? Is it our memory? What is it, right? And so we need to systematically explore that. And then finally, we need to look at what is called aptitude-treatment interactions. So aptitude-treatment interactions essentially checks what type of instruction for what type of learner, for what aspect of language. So what we're trying to do is here to adapt the instruction to suit especially the learner, right? In the past, this wasn't possible because you couldn't adapt in your classes to every specific learner because there's so much variation. But with technology, it starts now being possible. That's called aptitude-treatment interactions, combining the best type of instruction or the optimal type of instruction, considering the learner background. Okay, so let me thank you again for your attention, and also to my students as well for coming. And so we have at least 10 minutes or so for questions. Thank you very much.
Okay, thank you. My question is actually a philosophical one. My question is, how the theoretical distinction between explicit and implicit learning is quite clear. I wonder, is there a form of learning that exists in literature? Something like selling explicit or selling implicit? Or do you think that there's room for defining this kind of implicit kind of learning? Actually, two questions. Now I you know, based on your educational background, I assume you are you might be linguist. You might be able to speak, I would say, German, right? And English working, and in UK, you must be able to speak Portuguese. So it's languages. So I was wondering, could you please share your learning experience with that? And during your learning experience, so do you pay more attention to English learning or English learning? That is my two questions.
So just with regards to the first question, so the way, remember, this is when I talked about implicit and explicit learning, these are the ways, these two modes of learning are usually defined, right? So you look at implicit learning. If you want to observe implicit learning, typically you need incident learning conditions. People are not supposed to know what they're supposed to learn. They don't know the target. Because guess what? If you tell people, if people think, yeah, I think it's about this, they'll try to figure it out. That's the problem. The problem is when the learning target is very complex, people will fail. They can't do it. So in our experiments, what works best, you know what it is? Not doing anything. Just listen to the sentence and responding, that's it. And you learn. And then often people at the end, they tell me, hey, sorry, I didn't even know it was supposed to be tested. I'm so sorry. They think they have learned. And I look at the data, yes, they do. And that's the power of implicit learning. But what you notice here is that there's something empty here, right? And something that doesn't have a name. So the truth is that even under incidental conditions, when you don't know what you're supposed to learn, you're just learning from exposure and from interaction, for example, you will become aware of some things. Of course you will, especially with adults, right? You notice some things. We see this in our experiments. Sometimes people notice stuff. Hey, I think the verb can come at the end, for example. They might not notice the whole thing, but they notice some things. So I don't think there's like an intermediate thing in between the two, but there is certainly, with these type of experiments, with adults learning language, you don't have a mechanism in your head where you turn off one or the other, right? It's not just implicit, just explicit. With real language, with real people. So if under incidental learning conditions, typically most of the knowledge will be unconscious, but people will become aware of some things. And that's very good because when we see in our experiments, when they become aware of some things, they tend to learn more in the end. Then you have the two things happening in parallel. You have the tracking of the statistics that I showed you, the cross-sectional statistics. That's what we call bottom-up. And then you have top-down knowledge guiding your attention. And then the same with explicit, right? So explicit learning, if you want to study it, everybody will tell you it needs to be intentional learning conditions. People need to know what they're supposed to learn and that they're going to be tested afterwards. Okay, that's intentional learning. And most of the knowledge that they develop then is explicit. However, in the experiments, we also see that some will be here. So even though you told them to figure out some stuff, some things they will have learned, but they cannot explain it. And again, it is because in your head you don't have a switch that says it's only implicit or it's only explicit. Right? The reality is often much more interesting than this. If you look at this across the lifespan, right, implicit learning is what comes first. That's something we share with other animals as well. So there are a lot of experiments that you can do with humans and other animals. You can do this with monkeys, with pigeons. Very basic learning of patterns is the same across lots of species. Okay, the idea is this is earlier from an evolutionary perspective. What is more recent is the explicit stuff. The explicit stuff, consciously doing stuff, that's more recent in terms of human evolution. Which also means that the implicit mechanism, the brain structure underpinning implicit learning is usually better protected. It's further down in the brain. And so you have people who suffer a lesion to the brain where the explicit goes, this thing goes, but the implicit is still working. Anyway, so this explaining a little bit the relationship between the two systems. So I think the two systems are always operating, always, whether you want to or not. And that's good because that allows us to be very efficient. So in terms of my background, so I grew up with two native languages, German and Portuguese. My mother is Portuguese, my dad is German. And so I really grew up bilingual with two native languages. I think most of you will be very similar to me in that regard, because if you've grown up in Asia, for example, in China, there's a lot of you will speak Mandarin, well, all of you will speak Mandarin, but you'll also speak something that you often call our home dialect, whatever. These are often very different. As linguists, I call them different languages. They're often not intelligible. So all of you, I suspect, are simultaneous bilinguals like me, right? And then I learned in school, I learned English from the age of 10, and then I learned French as well. It's compulsory, right? So I learned, and to be honest, I think it's so, I'm assuming most of you, has anyone grown up just with one variety of Chinese? Must be really rare. There you go, all simultaneous bilinguals. In addition to that, all of you, of course, are late bilinguals as well, because you learned English. All of you have learned English as well, and then you might have learned other languages as well. One thing that is very interesting, actually, that we're exploring in our research now is, does that make a difference in terms of learning more languages? So maybe last November, I gave a talk in this very room, public lecture to celebrate the 50th anniversary of my department, the Department of Linguistics and English Language. And one thing that's really interesting is that there's very clear data in medical research and neuroscience that show that people who speak more than one language, all of us, right? Like all of us, they show a delay in the onset of Alzheimer's symptoms by usually around 5 years. It's very clear results, multiple meta-analyses across in Canada, in the United States, and right, you still get the disease. However, the symptoms show up later, which means you have greater quality of life. And so the interesting thing here is that probably the reason why this is because when you speak multiple languages like we do, remember there are always other languages here in our heads. So we always have to suppress them. So at the moment, I need to push down my German and my Portuguese because I'm speaking English. I'm controlling this. You podia agora falar em português, dann könnte ich auf Deutsch sprechen, then I can go back to English. But I have to move them down, right? Because, and all of us are doing it all the time. So what this does is it kind of is like brain training. It gives you a cognitive reserve so that when we get older, right, we start, and we all get older, all of us, and we all decline, the brain declines, all of us. However, if you're multilingual, you have a reserve, you start higher up, right? And so there's the decline, but it's higher. So this is the cognitive reserve. So one thing that we're very interested in, that, for example, Chopin is looking at, is does it make a difference if you speak multiple languages and when you're learning new languages? For example, we can measure how multilingual people are. They get a score. In fact, we've done this as well with Cindy. We've looked at L1 Mandarin speakers in China learning Portuguese, and we looked, is it the case that people who speak more than one language are the better learning a new language? If they are, we think that might be because they have better attention, inhibitory control. And so when they learn a new language, like Portuguese, right, if you're multilingual, you suppress the other ones, and it's easier for you to learn the new one. That's the basic idea. So all of this to say, so we're looking very extensively in the effects of multilingualism. The good news is all of us are multilingual. The world should be more multilingual because it's good for your health as well.
Okay, thank you very much. Really appreciate it. More questions? More questions? I think we still have some time to go. Okay.
All right. Thank you very much for your wonderful presentation. I'm very interested about the second study you shared. So according to your result, then you showed, you found that the instruction about the tonal doesn't really significantly help their learning. So do you think it is has something to do with the training you did before the instruction part is actually about the one syllable and one tone attached to each syllable. But actually in the real learning and the testing part, you assign the disyllables, like actually two tonals like together. But actually in real Mandarin, we have Sandai, and the challenges of differentiated tone pairs is more difficult than just one tone. So that's why in teaching practice, we always teach like tones with one syllable first, and then we gradually move on to disyllabic practice and then trisyllabic practice. So that's my first question. And I also have a second question that's actually related to this one. So I wonder why you assign like the disyllable tonals to one character, because that doesn't fit the reality of the Mandarin. Most of the characters actually correspond to one syllable. So that's my two questions, and thank you.
So remember, so in this case, so the two are, well, the first answer is, this is the first experiment we did where we looked at the manipulation of the explicitness. And you're right, so there could be loads of different ways of doing it. The problem is we couldn't do all of it in one experiment, right? So the interesting thing is here saying, okay, what would be the optimal way of teaching it? I do think that explicit instruction is very important. Well, both are important. The implicit part is very important, tells us what you don't need to teach because people just learn it. And then the key thing is what they struggle with, that's why you have the explicit. But the optimal way of explicit instruction is an empirical question. We need to try it out. And what works well for some learners doesn't work well for others. So I'll give you an example from work we've done with the acquisition of grammar. What we found, not with, in this case, was German grammar. It's explicit instruction of German grammar works, however, only for people with good memory. tough. If you don't have good memory, it's tough. Which makes sense, right? Because if you cannot remember the rule in your head, you cannot apply it. And so in this case, for example, you're right. So for example, in this case, we just tried it out because we want to, so experiment 2 is very similar to experiment 1. We wanted to make as few changes as possible so we can compare. That's why we didn't make more changes. If we were to do this again, yes, so maybe it would be interesting to look at how you would typically do it in the classroom and so forth. You would do it more realistic. But we couldn't do it because then if you make a lot of changes, you cannot compare the 2 experiments. And the other things we cannot do is we cannot have too many groups because you cannot have 8 groups in one experiment. It becomes, you need a lot of hundreds of people. So the experiments we do is always like small changes to the previous one. We did the first one, then we make a small change, a small change, a small change, and then we see over time how it affects learning. So it's a good point. We just felt this was, to be honest, I thought it would be very easy. I thought people would easily, I thought it would be a big difference. And it didn't.
Okay, thank you very much. And I'm really looking forward to see the actual paper. Yes, thank you.
No, so the paper, so I need to leave in a few minutes. But remember, so I'm back tomorrow. I'm from the coffee break tomorrow morning. I'm there and I have lunch with you as well. The actual paper is coming out in a special issue, so I hope you all read it, of the Chinese Journal of Applied Linguistics. Is coming out in 2026. And the special is called New Trends in Chinese as a Second Language, based on a conference that we organized here last year, 2024, maybe 16 months ago. And we organized here on campus with the Confucius Institute as well. So there will be a special issue looking at, okay, what is new in Chinese SLA from a research perspective.
All right, thank you. Do we have time for one more question?
Yeah. Well, I have time for one quick question. And then I'll come back. I promise I'll have lots of time tomorrow as well. Mm-hmm. Yeah. Yeah. Yes, I do. And it's not just my intuition, we have evidence for that. So we've done recently a study that we're currently writing up where people learn Chinese words, these words. And in this case, they also need to do production. They have to repeat the word out loud. Okay, and we have 2 groups, English native speakers and Thai native.